Chapter 8. So, Chapter 8, we're going to move on from radical equations and functions to quadratic equations and functions. And we're actually going to start this one in a bit of a reverse order. I really like to do the quadratic functions first. I like to look at the picture of what we're going to be solving for before we solve it. So, we're going to do quadratic functions and then we'll do quadratic equations. So when we're talking about graphs of quadratic functions, the first thing we have to do is determine how do I I didn't want to use the word determine again, but how do I know that I'm looking at a quadratic function? Well, a quadratic function can be written in the form f of x or y is equal to ax squared plus bx plus c. And really the most important thing is there has to be a term with a squared variable. So it says here that a, b, and c have to be real numbers, not a big deal. But the key thing is that there has to be an a value. So there has to be an x squared term. When we graph quadratic functions, the shape that we get is called a parabola, or it's a parabolic function. It's this U shape. And what we're going to look at first is some features of a quadratic function. So when you're talking about this parabolic shape, one of the key features of it is called the vertex. The vertex is either the max or the min point on the curve. So it's the very top or the very bottom. So if you look here, this would be the vertex. And then another feature that we like to look at is called the axis of symmetry. The axis of symmetry is kind of what its name implies. It's a line or an axis that will break the parabolic function up into two halves. So if I was to draw a vertical line passing through the middle point, so the vertex, I could fold the graph over this line and it would be perfectly symmetrical. So it's an axis of symmetry. And the equation for the axis of symmetry is always a vertical line. So it's always x equals. So the axis of symmetry is always represented by an equation of a vertical line, which is an x equals equation. And then the other thing we like to look at is whether the graph is opening up or down. If the graph is opening up, you will have a minimum. And if the graph is opening down, you will have a maximum. And in another lesson, we're going to be solving applications of these quadratic functions, and we're going to be looking at maximum and minimum problems. So, where do we start? Well, we start with the most basic quadratic function, which is f of x is equal to x squared. In other words, y is equal to x squared. Anytime we graph anything, it's nice to start with a table of values. So we're going to pick values of x and we're going to solve for y. So we're going to pick something like -3. When x is -3, the y value is -3 squared, or 9. Then we're going to put in x is -2. -2 squared is 4. -1 squared is 1. 0 squared is 0. And then we get to repeat it because -1 squared is 1 and 1 squared is 1. -2 squared is 4 and 2 squared is 4. -3 squared is 4 and or is 9 and +3 squared is 9. Then when we graph this function, what I'm going to do, because I don't like to have to do a table of values every single time, so I'm going to try to wean you off of these, is that I will start with my max or my min. So for this case, it's going to be that 0, 0. It's the point where the graph was symmetrical. So I'm going to start with 0, 0, and I'm going to notice that from this point, 0, 0, which is my vertex, my graph is going to go over 1 and up its square to 1, over 2 up its square to 4, and over 3 and up its square to 9. And then talking about this folding line or this axis of symmetry, all of these points will occur across the axis of symmetry. So you can actually take them and copy them over to the other side. Or you can do, again, over 1, up 1, over 2, up 4, over 3, up 9. And that is the basic shape of a parabola. And we're going to practice graphing this over and over and over again until that shape feels very familiar. Okay, so this is my base parabolic function or my base quadratic function. It has a vertex at 0, 0, and then the axis of symmetry always runs through the x value of the vertex. So I could draw a vertical line through x equals 0, and I would be able to fold the graph in half. Another feature that we like to talk about when we're talking about graphing is domain and range. The domain of every parabolic function is negative infinity to infinity. There's nothing I can't square. But because of the square feature, the graph opens up. So my range will be 0 with a square bracket, because there is a point at 0, and then all the way reaching up to positive infinity with a round bracket. All right, now what we're going to do is we're going to take this graph and we're going to graph it over and over again with just a couple little feature changes. So the first one we're going to look at is y equals x minus h all squared. And we're going to look to see what happens when you put an h in the bracket with the x. Now what I've done again is just pick some values of x that I want to plug into the equation and solve for y. Now I had to pick a lot of them so that you could see what I want you to see. But all I want you to do is maybe pause the video or go along with me and plug in the values of x and solve for y. So for example, negative 4 squared is 16. Negative 3 squared is 9. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. And 4 squared is 16. And I want you to see that this is my base parabolic shape. Now what's going to happen if I put a plus 2 in the bracket with the x? Well, let's plug in values of x. So if I plug in negative 4, I've got negative 4 plus 2 all squared, which would give me negative 2 squared, which is going to give me a y value of 4. When I plug in negative 3, I get negative 3 plus 2. And when I square it, that's negative 1 squared, I get 1. It's kind of feeling like this. Let's see what keeps happening. When I plug in negative 2, I've got negative 2 plus 2. Oh, that's 0 squared, which is 0. Huh. Keeping on going. When I plug in negative 1, I've got negative 1 plus 2 squared, which is going to give me 1 squared, which is 1. If you think about the pattern, that means I'm probably going to get a 4 here as well. Let's test it. 0 plus 2 all squared is going to give me 2 squared, which is 4. When I plug in 1, I get 1 plus 2 squared. Oh yeah, that's 3 squared. There's that 9. Okay, I'm getting this, which means that I'm going to predict the next number is going to be a 16, and then maybe a 25, right? 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So this would be 6 squared, which would be 36. Let's check it. So when I plug in 2, I've got 2 plus 2 all squared, which gives me 4 squared, which is 16. This is going to give me 3 plus 2 all squared, which is 5 squared, which is 25. This is going to give me 4 plus 2 all squared, which gives me 6 squared, which is 36. Interesting. So let's keep going. Let's do this other column, and then we're going to graph them and determine the vertex, axis of symmetry, and so on and so forth. So let's see what happens when I put a minus 2 in here. This time when I plug that in here, I get negative 4 minus 2 all squared. That's negative 6 squared. Oh, there's that 36. And if you think about these being perfect squares, maybe you're starting to see the pattern. Maybe you could go 25. Maybe you could go 16. Maybe you could go 9. Maybe you could go 4. Maybe you could go 1. Oh, there's that 0. And then I could go 1. And then I could go 4. Can you see what's happening? If you can figure out where your vertex is, it's always over 1 up its square, over 2 up its square, over 3 up its square, over 4 up its square, over 5 up its square, over 6 up its square. There's this patterning around the vertex of a parabola. If you don't trust this, right, just go ahead and keep putting in the values of x. Negative 3 minus 2 all squared gives me negative 5 squared. Oh, look, 25. Then I'm going to plug in negative 2. Negative 2 minus 2 all squared is negative 4 squared, which is 16. Then I've got negative 1 minus 2 all squared gives me negative 3 squared, which is 9. I'm getting that predictable pattern. Now, what does that mean? Well, and again, keep filling this in if you don't trust it, but if you trust it, let's go down and plot these graphs. So I'm going to just minimize here so I can see. I'm going to graph my basic parabola. That's a little too small. You probably can't even see it. Okay. Oops. Where'd it go? Here we go. So I'm going to graph my basic parabola. So I'm going to start. I know that a basic parabola has a vertex of 0, 0. Let's just fill that in here. So this one had a vertex at 0, 0. I know that means it has an axis of symmetry at x equals 0, and there are no transformations, right? This is my base graph, but I'm going to graph it. So from the vertex, over 1 up its square, over 2 up its square, or just following those pairs, the points above, over 3 up 9, and that's all I can fit on my grid. Okay, that is my basic parabola. This is y equals x squared. The next one that we're going to graph, let's just do it in a different color. Let's graph y is equal to x plus 2 all squared. Now, can you see where the vertex is? Right? So for this one, the vertex was at 0, 0. And then everything went symmetrical from here. It went 1, 4, 9, 1, 4, 9. For this one, the symmetry is going to happen around here at negative 2, 0. 1, 4, I would assume 9, and so on. Over here, 1, 4, 9, 16, and so on. So if I was to sketch this one, the biggest difference is that my vertex is going to start at negative 2, 0, which means my axis of symmetry will be at x equals negative 2. Let's take these points and let's graph them. So let's start at negative 2, 0, and then check to see if I can do that same pattern. Over 1 up its square. Do I have that point? Negative 1. Oh, look, 1. The next point would be at 0, 4. 0, 4. From the vertex, that's over 2 and up 4. If I wanted to do the next one, right, we said that it was going to be when x is 1, y is 9. X is 1, y is 9, but instead of using a table of values, I could have gone over 3 and up 9, which means if I wanted to do the other side, I could keep following my table of values, or I could go over 1, up 1. I have a point at negative 3, 1. Over 2 and up 4, I have a point at negative 4, 4. Over 3 and up 9, I have a point at negative 5, 9. And I get this base parabolic shape. But how would you describe the graph? Where did it go? Right? So if I was going to describe how this red graph compares with this blue graph, what would you say? Well, it's gone to the left too, which is kind of weird, right? So the equation said x plus 2 all squared, and that made my graph go left too. Now, listen to my reasoning for this. We wanted to get 0, 1, 4, 9, right? So for example, to get a y value of 0, I wanted 0 squared. Because the equation made me add 2, I actually had to take my x value and decrease it by 2 so that I could get negative 2 when I added 2 back to 0, right? Same thing here. When I wanted to get negative 1 squared, I had to put in negative 3 because then the equation made me add 2. So when your equation has an x plus 2, you actually have to decrease your x values by 2 to get the same shape. In fact, I'm just going to switch over to Desmos for a second. Okay, so here's that base parabolic shape. And look, I've put all these equations with plus. We already said that when it's x plus 2, the graph got moved to the left too. If I was to do x plus 3, where's my vertex going to be? I had to decrease my x values by 3 so that when the equation adds 3, I can get to the same place. In other words, my vertex, when I put in x equals negative 3 plus 3 is 0, I get that 0 squared is 0. So this graph is my original graph moved to the left 3. My vertex is at negative 3, 0. When I have x plus 4, it's moved to the left 4. If I have x plus 5, it's moved to the left 5. When you have x plus 6, it's moved to the left 6. So in general, we could say that when it's an x plus, my graph will move to the left. In fact, you know what? Let's put this down here. How will the value of h transform the graph? When you have x plus anything, it's going to go to the left. All right, now let's do this again and look to see what happens if I have an x minus 2. Okay, can you spot where the vertex of this graph is? So we're looking for that pattern of the y values going 0, 1, 4, 9, right, on either side. And this time, I hope that you can see it down here at 2, 0. This graph will have a vertex at 2, 0, which means the vertex, or the axis of symmetry, would be at x is equal to 2. Where's this graph going to go? Well, let's graph it. Let's put that vertex at 2, 0. If I do my regular shape, over 1, up 1, over 2, up 4, over 3, up 9, and on the other side as well, over 1, up 1, over 2, up 4, over 3, up 9. Does that match the table of values that I picked? Well, let's check some points. So we've got that point at 2, 0, right? We have a point at 3, 1, and we have a point at 4, 4. The other way, we have a point at 1, 1, and then we have a point at 0, 4, and then we have a point at negative 1, 9. So how would you describe the purple graph compared to the blue graph? Well, you'd say that it's been moved right 2. And in fact, if I went back to Desmos, right, and I went into all of these equations, let's get rid of them all. And then as I reveal them, let's put a minus sign in here instead. What happens? Well, this has been moved right 2. My vertex is at 2, 0. This one's been moved right 3. My vertex is at 3, 0. This one has been moved right 4. My vertex is at 4, 0. This one, if I put it in, hopefully this is getting repetitive for you, right? This has been moved right 5. And then lastly, this one, it's been moved right 6. So in general, we can say that when you have a bracket that is x minus some value, that it's been moved to the right. We can also generalize that the value of h is moving that vertex left and right, and in fact, it is the x value of the vertex. I'm going to go back to blue. This purple's a bit light. So I'm going to say that my vertex is at h, and for all of these, it's at h0. So when you think about this, again, I just want to reiterate that the equation is x minus h. So when you put in a positive value for h, it looks negative, right? So if I put in h is 3, so if you have something like x minus 3, that means that the h value is 3, right? H value is 3, and it'll be moved to the right. If I had something like x plus 3, that means that it was x minus minus 3. So for this one, you'd have a negative h value, and your vertex would be at negative 3, 0. And then the axis of symmetry always runs through the x value of the vertex, so it's going to be x is equal to h. So now hopefully you get the concept. I just want to practice one more before you go on to do your worksheet. So if I just asked you from scratch, graph y equals x plus 4 all squared. I want you to be thinking that this is the shape of a parabola because it's an equation squared, right? Versus y equals x plus 4, which would just be the graph of a line. And so we have to think about where our vertex will be, because wherever our vertex is, then our shape will come from there, where you'll be symmetric across the axis of symmetry. So what I recommend doing is looking at the bracket and potentially treating it like a factor, right? So if we say x plus 4 is going to equal 0, then we're going to minus 4 from each side, and we get x is equal to negative 4. I find that works for most people, even though we aren't actually, um, sorry, even though we aren't actually solving a quadratic. I find just the act of saying, okay, this is in a bracket, set your bracket equal to 0, and then solve. We get x is equal to negative 4. That gives us our axis of symmetry, which is going to be the x value of our vertex. And I find that's usually enough for people. Some people really are kind of purists and they're like, okay, it's x minus h all squared. So in order for this to be positive, the h value has to be negative. But I find that's more confusing. And then from there, okay, you can plug that value of x into the formula. So you would end up with y is equal to negative 4 plus 4 squared, which is going to give us 0 squared, which means our vertex is going to be at negative 4, 0. This graph is going to start at negative 4, 0. And actually, I'll just shrink this down so we can fit it all on one page when you're looking at it. Okay, so then we have to figure out some other x values, and you always just go 2 down and 2 up. And then when you plug those in, you'll get your shape. If you're getting good at at graphing quadratics, right, you can just go from the vertex, go over 1, up 1, over 2, up its square root of 4. You could go even over 3 and up its square root of 9 if you're doing that, and mirror them on the other side, or you plug them in. So you go y equals -5 plus 4 all squared. I really hate how my 4s always look weird, which is going to give me -1 squared, which is 1. So I'm going to have a point at -5, 1. Then I'm going to plug in -6. Which is going to give me -2 squared, which is 4. I get that point here. And then, of course, if I go the other way, I get y is equal to -3 plus 4 squared, which is going to be 1 squared, which is 1. And if I plug in that -2, I end up with 2 squared, which is also 4. So I get these points that I would get by doing the shape. It just depends on how your brain works. Does your brain want to just plug in values of x? Like the key thing is knowing where your vertex is, right? That's your starting point, 2 up, 2 down. And then you'll get the shape of the parabola. If you don't need the table values because you understand the shape of a problem, that's cool too. It's kind of a choose your own adventure. But I want to see at least 5 points clearly shown, and then connect your dots in a parabolic shape and call it good. Well, that wasn't so great, but you know what I mean. And then write the domain and range. The domain of this quadratic is going to be -infinity to infinity, like all quadratics are. And then the range is going to be from 0 up to infinity round bracket. Awesome. Awesome. Okay, so that is the first part of your worksheet. So your homework, because the textbook goes too hard too fast, you're going to be going to your practice questions, and you'll notice that the first topic is y equals x minus h all squared, and then there's just a couple questions that you are going to graph. So y equals x minus 3, y equals x plus 5 all squared. You're going to determine what the vertex is, what the axis of symmetry is, and then I want the correct graph. As you go through, don't forget to check your answers. So scroll to the back, there are the correct answers to each of the graphs. Okay, so it's just a couple questions, give them a go, and hopefully that'll make sense, and we'll move on to the next transformation.